In the required prior knowledge, we saw that the sum of this infinite series was equal to 1 over 1 minus x. Now 1 over 1 minus x we can rewrite as 1 minus x to the minus 1. But what that means is this binomial, 1 minus x to the power of negative 1, is equal to this expansion. Now this gives us a way to expand binomials to negative powers. So in the previous skill we saw expanding binomials to positive powers. In this skill we're going to be looking at expanding binomials to negative and then fractional powers. So using this, we're going to work out what 1 minus x to the minus 2 is. So 1 minus x to the minus 2 is equal to 1 minus x to the minus 1, which is this thing, squared, which is 1 minus x to the minus 1 times 1 minus x to the minus 1. So let's think about what that is. That is, well, 1 minus x to the minus 1 is 1 plus x squared plus x cubed, going on forever, and then multiplied by the same thing. Let's see what happens as we expand this. First of all, we're going to multiply 1 by everything here. So we're going to get 1, we're going to do 1 times 1, and then 1 times x is going to give us plus x. 1 times x squared is going to give us plus x squared. 1 times x cubed is going to give us plus x cubed. I'm going to write a few more terms. It's going to give us plus x to the 4 and plus x to the 5 and so on. Now when we multiply the x by each of these things, we're going to get x times 1. So we're going to get a plus x. Then we're going to get x times x. So we're going to get a plus x squared. We're going to get x times x squared is going to be a plus x cubed. X times x cubed going to give me an x to the 4, an x to the 5, and so on forever. When I multiply the x squared, I'm going to get x squared times by 1 is going to give me plus x squared. X squared times x is going to give me x cubed. X squared times x squared is going to give me x to the 4. And x squared times x cubed is going to give me x to the 5. Forever and ever and ever. And I could keep going along this pattern, keep expanding, but by this point, hopefully we can see what's happening. Now I've lined it up here to make it easy to see what's happening and how we can combine these. Here we have got 1, and then we have got 2 x's, and then we've got 3x squareds, and then we're going to have 4x cubes, because we're going to have x cubed times by 1 in the next one. And then we're going to have 5x to the 4s, 6x to the 5s, and so on forever and ever, following this pattern. And so using this, we've worked out a way to expand 1 minus x to the minus 2 as an infinite series. This is an infinite sum. What about if we were thinking about 1 minus x to the minus 3? Let's have a think about what that would be. 1 minus x to the minus 3 would be 1 minus x to the minus 1 times by 1 minus x to the minus 2. So that's 1 plus x squared plus x cubed, going on forever, times, and then this bit is what we just worked out, 1 plus 2x plus 3x squared plus 4x cubed, going on forever and ever. And doing a similar thing, when we multiply this by the 1's, we get 1 times 1 is 1, 1 times 2x is 2x, 1 times 3x squared is 3x squared, plus 4x cubed, plus 5x to the 4, going on forever. Now when we multiply the x's, we're going to get x times 1, so we're going to get plus x. X times 2x is plus 2x squared, plus 3x cubed, plus 4x to the 4. And then the x squared times by 1 is going to give us plus x squared. X squared times 2x is going to give us plus 2x cubed. X squared times 3x squared is going to give us 3x to the 4s, and so on and so on. And this time we're going to get 1 plus 3x plus 6x squared plus, then it's going to be 4 plus 3 plus 2 plus 1x cubed, so that's 10x cubes. It's 5 plus 4 plus 3 plus 2 plus 1, which is going to be 15x to the 4s. And you might have spotted there the pattern is, well, these are the triangular numbers because each of these coefficients is the sum of all the integers from, in this case, 5 down. 1 more than the power down to 0, down to 1. So we get the triangular numbers here. Now, this is a rather long way to go about this. And what we're going to see in this lesson is how we can use a formula to help us find these results a little bit more quickly than having to go through this process every single time.